Good afternoon. My name is Ben Potter. I'm an application engineer at Concepts in Production. I have a Solidworks certification expert, and I will be talking about the 3D printing design tools that Solidworks has in its program to help design your models for 3D printing. The traditional method, CNCs and lathes, is subtractive manufacturing, and the only real benefit it has is a lower material costs overall. Buying stock standard size pieces can be cheaper on the forefront, but you lose a lot of money in material waste and the boundary plate that you can cut your shapes and designs out of. And then one of the biggest things that holds subtractive back is the geometry limitations. If your tools cannot fit where the material needs to be removed, then that part can just not be created. And now additive manufacturing or 3D printing, it benefits because there is very little waste as the part is built layer by layer. Waste there is support material, and that allows you to make the complex shapes. You just remove the support at the end. And one thing we'll talk about and show later is you reduce the support by designing your models to not have it, and that'll save you the material waste and save you money in material cost. There's a variety of technologies and materials with 3D printing, and you get a very high return on investment because you need faster time to market, it's lower costs, you can prototype faster, you can print something and have it in hand to really see how it'll work in your design application much quicker than paying a machine shop and expediting it to get it there. Now, material cost can be high, and that's kind of the key word is the can, because it all depends on what your 3D printing material is. If you're printing ABS, which is a pretty standard material, that's a pretty cheap plastic. But if you're printing something up to some of the nylons and even carbon reinforced nylon, then your price can get higher. So it all depends on the application that you're trying to achieve. Solidworks has 3D printing tools in the Print 3D option, and a few of the key points that it has is you can set the printer size, the build volume, so you can make sure your parts fit, and it gives other tools that we'll take a look at to force the part to fit, or if the orientation needs to be a certain way to fit it within the build size. You can see where support will be applied, which is key to knowing if surface quality is a big issue. The support will have to adhere to the layers to support the overhanging faces, and those faces can be a little distorted because of support material. Next, you could view a bump map or a striation lines for the print layers, and this really shows how the layers will print, which is really key in holes and curved surfaces, so that you say how the stepping of the printer will affect the surface quality of those holes. You can analyze the wall and gap thicknesses, and that really shows you a good indication of whether your walls are too thin or your gaps are too thin, and that can lead to bad print quality. So we're going to get over into SolidWorks now. So here's the part that we have, and you simply go to File and Print 3D. And initially, which I've already selected it, but initially it'll ask you to select the bottom plane of the model or the ground plane. So if you did want it to print like that, you could, but we want it to print like normal. Now here we have the build volume is for our smaller printer we have in-house, and it clearly shows that it will not fit. So we will bump this up to our much larger print volume that we have, and it will fit very easily. And so now that we know that it fits, we will move down. Again, this is where the orientation options are, and you can move these manually, or if you have a part that has very unique geometry or is very close to the max build volume in a certain direction that you're not sure how it could fit, you can press the Orient To Fit button, and that SolidWorks will pick the most optimal orientation where it is the farthest from the build edges. And I'll do that here with this part, even though it fits easily. And all it does is shift it down and rotate it so that all points are as far as they can be from the outer build volume. So I'm going to just move these back so that it is normal orientation, since our part does fit easily. And now they have a scale feature, which you can scale it here. You can also scale it in the model, but scaling it here doesn't affect the actual model once you close out of the Print 3D. So definitely want to keep that in mind if using these tools. And this is useful if you were doing scale models or miniatures of a building layout or a plant layout. They also have a scale to fit, so you can increase the size of the part fully. If maybe a display piece, you just wanted to print it as big as possible to show a customer or a manager. And then they have options here, because if you have a printer connected directly to your computer and the proper print drivers through Microsoft, you can actually print directly from Solidworks to your printer, or you can send the information straight to your printer. The options here are just quality, infill, include support, and then raft, which is a technique to help adhere material to the build plate. And then there's the save file option, which is the three most standard: STL, 3D manufacturing format, and additive manufacturing file. STL is the standard. Most third-party softwares or proprietary softwares that come with printers will read STLs. The other two are usually read as well. Now that we have gone through that, we'll go to the preview or the analysis section, and we'll do show faces that require support. Now I'm going to change these colors to better view the part, and that's a nice option. You can change the colors if you've maybe got some color-coded requirements, or just you want to see it easier than what default is. And you can set your angle. Most printers, 45 is the angle, but there are a few technologies in 3D printing out there that may use a different angle than 45. As we can see here, where the support will be applied to the holes, the overhang here in this area. And nice is we can just do show transparent, which is ultimately quicker and easier, and it really just gives you a good idea of where support will be. So we'll turn that off, and we'll come down to the striation lines. So striation lines show you the layers that will be printed, and you can do a bump map, which gives you just a good, a little cleaner look, and it utilizes the real view graphics, so you have to have those turned on before you enter the print 3D options, and those are found just right here when you're in the model window, not in the print 3D feature manager. So right now we're at 200 microns, which is a little large, but it'll print faster if you just needed a very quick prototype. Most printers will print at 100 microns, and as you can see, the steps in this curve got a little tighter. And that's really what striation lines can really show you, is where these curved faces look as they transition out of the curve and into either verticality or horizontal planes. And finally, we have one of our printers here can print all the way down to 50 microns, and that improves the surface quality and the steps. Also at 50 microns, the surface quality will be more almost like a satin finish, like a matte look to it. And so we know, looking at this, we can see that if we really need a good view and aesthetics for these holes, that the smaller the material, the layer height, the better. But again, it all depends on the application that you're trying to achieve. So then we have the thickness and gap analysis tool, which you can use their drop down if you know the material that you're going to be printing with, or you can do a custom thickness, which is what we use, because our printer prints carbon infused nylon, and it prints at 50 thousandths of an inch. Anything smaller than that may run into problems. And so we'll calculate, and it very easily graphically shows you the problem areas. Here we have, thin walls. A thin wall may not have good adhesion to the next path next to it. I'll show that in the actual 3D printing software that we use to show that better. You could also get surface quality issues with thin walls, and then small gaps, thin gaps, they run the risk of either closing up if they're too close together. They'll just fuse right together and you won't have your gap, or the support that will be needed for the top would result in what is known as rat nests or bird nests, where the material just sags. And then here is a interesting case where the curve of the base and the straight line of the holding apparatus actually creates a very small instance of a thin wall. And we'll take care of that, but you could also ignore this if need be. So those are all the tools that SOLIDWORKS has to really analyze your model. And we're going to very quickly just make changes to the model real quick, and then run the analysis tool again, so that we can show that the model has been upgraded so that it is good for 3D printing. Now we add fillets under here so that we'll remove that thin wall, and then we can add a chamfer underneath this bottom face so that we'll remove the support, because that is quite a lot of support having to be laid all the way around this base and is up to the height of the bottom of that surface. So we'll add a little material to the final model, but we'll reduce material ultimately by not having the support. And then we'll also add a chamfer underneath the hole reinforcement material so that we also reduce further support. And so then we'll quickly come back to the Print 3D, go into the previews, and we can run the calculate check, and as you see, nothing shows up, so we have no thin walls and no thin gaps. And then we can check the surface support again, and we have no support being printed under here and no support being printed under there. So our model now is ready for 3D printing. I'm going to open up Eiger, which is Markforged's software for their 3D printing. These are the printers that we utilize. I have the bad part opened and the good part as well. To show the significance of support, on the bad part, 370 cubic centimeters of material is needed, whereas on the good part, even though we added material to the final model, with reducing the support cost, it's only 327 cubic centimeters. So we've saved 40 to 50 cubic centimeters of material, which correlates to about $10 worth of material cost. So that can be significant in larger parts or maybe more complex parts where you have a lot of support. If you can adjust it and adding chamfers or just remodeling it slightly where you still achieve the tolerances and functionality that you need but reduce the support, you can save a good amount of money. So then if we go to the internal views, we can see a little bit more of it. If we turn on only support material, and that'll just show again the fact that how much support we have removed from our model by just simply adding some chamfers. All these triangles here and then the entire circle support. Then we'll go to the 2D. So this will show thin walls, dangers of having too thin of walls. Here, when those thin gussets would be laid, they only get 2 passes. Now, if the passes are close enough, they will fuse together, but you'll have a very flimsy, easily breakable gusset. Or if they are too far apart, then they will actually have a gap in between the 2 paths, and that obviously they are even flimsier and weaker there. Whereas just increasing them by a little bit, we were able to actually get infill, and so these will be much stronger gussets. And then if we zoom out and look at the thin gaps, we can see that in the bad one there is no support being laid because the gaps are too close together and there is no room for support. If support was put there, then the gaps would just fill in, and at the top of these slots you would have the rat nesting or the bird nesting, and the aesthetics would be compromised. And so that is the tools that Solidworks has put into their software to empower the user to ensure that their models are the best that they can be for 3D printing.